So I was trying to get a standard image generator to create a diagram of a neural network architecture yesterday.
Well, how did that go?
I gave it a perfect prompt, detailed every layer, asked for a clean flow chart. What I got back was just a bowl of techno spaghetti.
I think I know what you mean.
Arrows pointing nowhere, text that looked like alien hieroglyphics, boxes just melting into each other. It looked cool, I guess, but it was scientifically just gibberish.
That is the classic generative illusion. Models like, say, Mid-Journeys are amazing, but they're built for aesthetics, not logic.
Right.
They don't understand that an arrow means data is flowing. They just know that in their training data, arrows tend to show up near boxes.
Which makes them pretty much useless for actual research. But I've been reading about a new framework from researchers at Peking University and Google Cloud AI that claims to fix this exact problem.
Wow.
It's called, and I promise I'm not making this up, PaperBanana.
It's a fantastic name, isn't it? It sounds like an item from a video game, but the engineering behind it is actually very serious. It's a multi-agent framework built for one thing: solving that blank canvas problem for academic illustrations.
Okay, so before we jump into the agents themselves,
Right.
why a framework? Why not just train one massive model on 1 million scientific papers and, call it a day?
Well, because a single model trying to do everything, the layout, the style, the logic, the text, it just suffers from cognitive overload. It starts to hallucinate.
I see.
PaperBanana treats making a diagram less like an art project and more like an engineering pipeline. It's set up like a little design studio where everyone has a specific role.
So you have specialists.
Precisely. It all starts with a retriever.
Yeah.
Now, if you give the system a block of text, say your methodology section, the retriever doesn't try to draw anything yet.
Okay.
Instead, it scans data sets, like all the NeurIPS papers, and it looks for structural matches.
So wait, it's not looking for papers on the same topic. It's looking for diagrams that have the same general shape as the argument I'm trying to make.
You've got it. It's hunting for the bones of the visualization.
Yeah.
Once it finds a good reference, it passes it over to the planner.
And the planner is the architect.
The architect, yes. It reads your specific text and figures out how to map your concepts onto that structure it just retrieved. This is what separates the logic from the pixels. Then the stylist comes in. It applies all the rules of academic style, the right fonts, color palettes, line weights, so it looks professional. But the real magic is in the next step.
This would be the visualizer and critic loop, right? This part actually reminded me of my day job.
Oh, yeah? How so?
It felt like a senior engineer doing a code review on a junior's pull request. The visualizer draws the image, but the critic doesn't care if it's pretty. It just reads the original text and asks, did you actually include the feedback mechanism from paragraph 3?
That is the perfect analogy. And they iterate, usually about 3 rounds of this code review, to just squash any hallucinations.
And this is why it performs so well on faithfulness.
Exactly.
Yeah.
This is why on their benchmark, which they call PaperBanana Bench, it just crushed the baselines. Standard models make beautiful lies. PaperBanana makes accurate, faithful visuals.
Speaking of accurate and automated workflows, this feels like a good moment to mention our partner Embersilk.
It does. If you're out there thinking, I need an agentic workflow like this for my business, you really need to check out Embersilk. They specialize in AI training, automation, and software development.
So whether it's building complex agents or just figuring out where automation can help you in your own life, head over to embersilk.com.
Now, there's one other detail in PaperBanana that I think is the real game changer. It solves the problem of lying with charts.
You're talking about the statistical plots. Because, yeah, if I ask an image generator to draw a bar chart showing 25% growth, it just draws a bar that looks tall.
Which is so dangerous in science. PaperBanana completely changes its strategy here. If the planner sees you need a plot, it doesn't ask the visualizer to draw it.
What does it do?
It instructs the agents to write Python code. Specifically, Matplotlib.
That is brilliant. It just bypasses the whole diffusion model. It's not guessing how tall the bar should be. It's executing code to render the real data.
Exactly. It guarantees numerical precision. You get the polish of a designer with the rigor of a data scientist.
They also mentioned this glow-up feature, which I guess is for people like me who start with sketches on a napkin.
Yes. You can feed it a rough, hand-drawn sketch, and the stylist agent just enhances it into a publication-ready figure. It keeps your logic, but fixes your crooked lines.
So if you just step back and look at the trajectory here, we have AI that can scan research, AI that can suggest hypotheses, and now AI that can clearly visualize the methodology.
We're getting very close to a point where the friction of just doing science is disappearing. The bottleneck used to be, I have this complex idea, but how do I even begin to explain it?
And now that barrier is just getting lower and lower. It really democratizes high-level communication.
Yeah.
You don't need a graphic design degree to publish a top-tier paper anymore.
You just need a good idea. And that is a huge net positive for human discovery.
A very cool glimpse into the future of research. If you enjoyed this deep dive, please subscribe to the show.
Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.